Introduction. In the new all-weather operations (AWO) regulations, EASA is applying a total system approach. In other words, they are addressing not only airline and pilot operations, but also expanding the regulations for airports, facilities, services, and streamlining the low-visibility operations with new definitions and allowing certain operational credits for the capability of certain modern aircraft, approach systems, and instrument approach procedures which are enhanced with recent technology. The latest changes began on March 30, 2022, when the aircraft equipment manufacturers were informed of the updates that will be required going forward to streamline the limitations and credits for existing aircraft equipment and airport limitations. On August 1, 2022, the limitations and credits will apply to aerodromes, which ensures the availability of aerodrome infrastructure, including meteorological equipment, information, and procedures to support AWOs. On October 30, 2022, the aviation operators' flight crew licensing requirements will begin to be enforced. At present, there is no real standardization between the certification of aircraft equipment and airport equipment, services, and facilities. With the total system approach to AWO, EASA is attempting to standardize the certification of all portions of the equation. Currently, airports have the equipment, airplanes have the equipment, and there are no real standards between the certifications of each. Runway suitability really should be determined by aircraft type and equipment, because trying to define what is regular, irregular, suitable, or not suitable doesn't really work unless you're thinking about what the aeroplanes are capable of accomplishing under current conditions. This program will not go into detail about low visibility operations, LVO, since the definition of low visibility operations extends to all those below an RVR of 550 meters. The LVTO concept of operations extends to all takeoffs with an RVR of less than 550 meters. However, they will require specific approval for those LVTOs with an RVR of less than 400 meters, continuous descent final approach, and performance-based navigation, but are covered in separate courses which will be edited to include some of the material covered in this program. List of regulations. The new CSAWO Issue 2 is divided into 3 subparts. Subpart A has all the info on the enabling equipment. ALS, HUD, EFVS, SVGs, CVS, and subparts B and C basically contain the performance requirements and airworthiness type stuff. EASA Implementation Document, October 15, 2022. Your document, 013. ICAO Annex 1, 4, 6, 10, 14. Advisory Circular 120-29, for U.S. operators. Aerodrome Equipment, Services, and Categories. Aerodrome Category A. A Category A is an aerodrome that meets all the following conditions and has a straight-in 3D instrument approach procedure with a glide path angle of not more than 3.5 degrees to each runway expected to be used for landing. At least one runway with no performance-limited procedure for takeoff and/or landing, such as no requirement to follow a contingency procedure for obstacle clearance in the event of an engine failure on takeoff from any runway expected to be used for departure. A night operations capability. The contingency procedures for obstacle clearance requirement implies that as long as one runway has no limitation on the engine-out contingency procedure for the intended operations, the airport will be categorized as a Aerodrome Category B. Is an aerodrome that does not meet the Category A conditions or which requires extra considerations due to having non-standard approach aids and/or approach patterns, such as restrictions on the availability of straight-in instrument approach procedures. Unusual local weather conditions, such as environmental features that can give rise to turbulence, wind shear, or unusual wind conditions. Unusual characteristics or performance limitations, such as unusual runway characteristics in length, width, slope, markings, or lighting that present an atypical visual perspective on approach. Any other relevant considerations, including obstructions, physical layout, lighting, etc., such as restrictions on circling in certain sectors due to obstacles in the circling area. Special training or flight crew experience requirements stipulated by the competent authority responsible for the aerodrome that does not include instruction in a simulator or visiting the aerodrome visit. Aerodrome Category C. This category requires additional considerations to those of a Category B aerodrome, or for which flight crew experience or qualification requirements are stipulated by the competent authority. About 90% of currently used airports already meet the requirements of the new regulations. The remaining 10% may require a safety analysis to see if your aircraft equipment can operate in these fields with limited lighting and ground, space-based navigational and approach limitations. Any safety review edits to the operations manual or required training should be noted by the operator. Aerodrome recency. The operations manual and the charts already include the necessary knowledge of obstructions, physical layout, lighting, approach aids and arrival, departure, holding and instrument approach procedures, applicable operating minima, and ground movements considerations. When the pilot hasn't operated at the Category A aerodrome in more than 12 months, the pilot simply needs to review its operations manual and the charts during the briefing to the aerodrome as means of initial familiarization training on the aerodromes, facilities, and procedures to be used. For Category B aerodromes and the pilot hasn't operated at the Category B aerodrome during the preceding 12 months, the pilot should complete the briefing requirements in Point C of AMC1, RO, FC105, B2C. For Category C. When the pilot hasn't operated at the Category C aerodrome during the preceding 12 months, the pilot should complete the briefing requirements visit in Point D of the same AMC. Aerodrome knowledge. Aerodrome familiarization training should include knowledge of obstructions, physical layout, lighting, approach aids and arrival, departure, holding, and instrument approach procedures, applicable operating minima, and ground movement considerations. The operations manual should describe the method of categorization of aerodromes and, in the case of CAT operations, provide a list of those aerodromes categorized as B or C. The completion of the briefing, visit, and/or instruction should be recorded. Runway types. With the new system of aerodromes and approach types, there is the new definition of runway types. The term instrument runway refers to the following types of runways intended for the operation of aircraft using instrument approach procedures. Non-precision approach runway, or a runway served by visual aids and at least one non-visual aid, intended for landing operations following a Type A instrument approach operation. A precision approach runway, Category 1, or a runway served by visual aids and at least one non-visual aid, intended for landing operations following a Type B, Cat 1 instrument approach operation. Precision approach runway, Category 2, or a runway served by visual aids and at least one non-visual aid, intended for landing operations following a Type B, Cat 2 instrument approach operation. Precision approach runway, Category 3, or a runway served by visual aids and at least one non-visual aid, intended for landing operations following a Type B, Cat 3 instrument approach operation. A non-instrument runway refers to a runway intended for the operation of aircraft using visual approach procedures. This implies that operators must request the corresponding approval in addition to aligning the procedure with the new AWO regulatory framework. New approach terminology. Annex 1 of Regulation EU 965/2012 has been edited to delete certain definitions that are no longer applicable, introduce those corresponding to new elements, and modify existing ones to clarify concepts and align ICAO definitions. A summary of the new definitions of instrument approach operations is 2D, 3D, with their corresponding categories, A and B, as well as those corresponding to the procedures, PA, LPV, and PA, to align it with the ICAO definitions. Likewise, the definitions of new types of operation, such as EFVS or EFVS 200 operation, are introduced. Since new terms are being applied, it's important to the new focus of the SPA part. The concept of operational credit is introduced. The operations of LTS Cat 1, OTS Cat 2, and EVS approaches disappear under the new AWO procedures. Type A approach operations. As defined by Regulation 2021-2036, a Type A instrument approach operation means an instrument approach operation with an MDH or a DH at or above 75 m or 250 feet. In the new regulation, a precision approach with minima above DH 250 feet would be considered a Type A instrument approach operation. Type B approach operations. A Type B, a decision height below 75 meters, 250 feet. Type B instrument approach operations are categorized as Category 1, Cat 1, a decision height not lower than 60 meters, 200 feet, and with either a visibility not less than 800 meters or a runway visual range not less than 550 meters. Category 2, Cat 2, a decision height lower than 60 meters, 200 feet, but not lower than 30 meters, 100 feet, and a runway visual range not less than 300 meters. Category 3, Cat 3A and Cat 3B are deleted. The new regulatory framework simply refers to Cat 3 operations. The concept of operational credits is introduced, which allows the application of reduced minimums to those aircraft that have equipment that is additional to that required as standard in relation to a given operation. The ED Decision 2022-012R has replaced the old Cat 3A with an RVR 200 meters and Cat 3 decision height 50 to 99 feet, RVR 175 meters. Cat 3 operations have several implications in AWO and in the Aerodrome selection policy. The lowest decision height values to be used for particular aircraft installations will be described in the AFM. The reference to the type of rollout systems used is included to allow the determination of the appropriate RVR value based on the pilots need to be able to control the rollout as a certification requirement. The lowest RVR for a decision height between 50 and 100 feet, previously Cat 3A, will be 175 meters, previously 200 meters, to be aligned with the new ICAO standard for Cat 3A. The provision for an RVR of 150 meters for aircraft certificated as Super Fail Passive is removed. For Cat 3 operations, the following should apply. For operations in which a decision height is used, the decision height should be determined by the use of a radio altimeter or other device capable of providing equivalent performance and be not lower than the minimum decision height specified in the AFM if stated. The decision height to which the flight crew is qualified to operate. Operations with no decision height should only be conducted if operation with no decision height is specified in the AFM. There is no published information indicating that the approach aid or aerodrome facilities cannot support operations with no decision height. The flight crew is qualified to operate with no decision height. The lowest RVR to be used should be determined per current tables. 2D and 3D approach operations. Two-dimensional, 2D, instrument approach operation means an instrument approach operation using lateral navigation guidance only such as VOR, NDB, LOC only, RNAV, LNAV only. This is what we used to refer to as a non-precision approach NPA. A three-dimensional, 3D, instrument approach operation means an instrument approach operation using both lateral and vertical navigation guidance such as ILS, MLS, GLS, LNAV/VNAV, and LPV, which we used to refer to as a precision approach. Other approach terms. Non-precision approach procedure is an instrument approach procedure designed for 2D instrument approach operations type A. Approach procedure with vertical guidance is performance-based navigation instrument approach procedure designed for 3D instrument approach operations type A. Precision approach procedure is an instrument approach procedure based on navigation systems, ILS, MLS, GLS, and SPOSCAT-I, designed for the 3D instrument approach operations type A or B. Technology assistance for approaches. Head-up display is a method of presenting flight information to the pilot in the line of their forward vision, which projects key flight instrument data onto a small see-through screen positioned just in front of the pilot's line of sight looking ahead out of the aircraft. Enhanced Flight Vision System is an aircraft system using a HUD or equivalent display to present aircraft information, flight symbology, electronic real-time sensor image of the forward external scene. Imaging sensors can be forward-looking infrared, millimeter wave radiometry, millimeter wave radar, low light level image intensification or other real-time imaging technologies. Enhanced flight visibility means the average forward horizontal distance from the cockpit of an aircraft in flight, at which prominent topographical objects may be clearly distinguished and identified by day or night by a pilot using an enhanced flight vision system. Flight visibility refers to a pilot's visibility using natural vision. Enhanced flight visibility refers to a pilot's enhanced visibility using EFVS imagery. EFVS-A is a system that may be used for approach operations down to a height of 100 feet above the runway. EFVS-L is a system that may be used all the way to landing. EFVS-L systems will additionally provide flare queuing and height information from a radio altimeter. EFVS 200, an operation in which visibility conditions require an EFVS to be used instead of natural vision to continue an approach to 200 feet above the runway threshold in other than LVO operations. It is an operation with an operational credit in which visibility conditions require an EFVS to be used up to 200 feet above the FADO or runway threshold. From that point to land, natural vision is used. The RVR shall not be less than 550 meters. Circling approaches. A circling approach operation refers to a Type A instrument approach operation to bring an aircraft into position for landing on a runway final approach and takeoff area, FADO, that is not suitably located for a straight-in approach. ED Decision 2022-012R has deleted the former point the RVR CMV derived for the preceding instrument approach procedure, which means that in the new regulatory environment there is no need to increase the visibility minima to the preceding instrument approach procedure. However, regulations maintain the provision to increase the DHMDA to the preceding instrument approach procedure. The intention of the regulation is that operators should provide guidance for the visibility needed when, for example, the circling OCH drives the MDH to higher values or when the operator uses higher values as a standard policy. In that case, the main factor to be considered is the distance needed to descend from circling minima to 50 feet above the runway threshold using a normal descent gradient. Determination of RVR or VIS for instrument approach operations. To determine the RVR or VIS for an instrument approach for aeroplanes uses the following criteria. The RVR or VIS for straight-in instrument approach operations should be not less than the greatest of the minimum RVR or VIS for the type of runway used according to Table 8. The minimum RVR determined according to the MDH or DH and class of lighting facility according to Table 9, or the minimum RVR according to the visual and non-visual aids and onboard equipment used according to Table 10. If the value determined in Table 8 is a VIS, then the result is a minimum VIS. In all other cases, the result is a minimum RVR. In Table 9 for Category A and B aeroplanes, if the RVR or VIS determined in accordance with Table 8 is greater than 1,500 meters, then 1,500 meters should be used. Establishing aerodrome operating minima. The starting point for the method for establishing aerodrome operating minima is the standard values provided by the service providers or instrument approach procedure charts, which usually cover the majority of aerodrome operating minima. Therefore, the operator's method should focus on the deviations, positive or negative, from those standard conditions based on the rules, the operation specifications, and circumstances applicable to each case. The method must be based on relevant safety assessments and described in sufficient detail to assure all risks are documented. Operational credits under AWO. The credit approval requirements for EVS capability differ based on whether the intended function of the system is to increase situational awareness or to obtain operational credit. If enhanced visual imagery is used to improve situational awareness, no operational approval is required. If the enhanced visual imagery is to be used for operational credit, the installed equipment must be certificated for the intended purpose. Such certification is described in the Aircraft Flight Manual or Flight Manual Supplement. Operational approvals require that the imagery is combined with flight guidance and presented on a HUD. Operational approvals may also require that this imagery is available to the second pilot either on a second HUD or a head-down display. The pilots can use this system to commence an approach in a lower RVR than would otherwise be permitted and to continue the approach below decision height provided that visual reference is available using the EVS. Operational credits for use of EVS HUD do not permit any change to published decision height. During all approaches using HUD EVS, the pilot must have the required visual reference without the use of the equipment, natural vision, no lower than 100 feet above the runway elevation. If the pilot does not have a natural vision by 100 feet, the approach must be discontinued. For EFVS credits allow approach EFVS operations, including in low visibility conditions, RVR less than 550 feet, and landing EFVS operations are considered operations with operational credits. Such operations will require the operator to hold specific approval from the competent authority. ICAO standards require specific approval for operations with operational credits. The term EFVS is introduced to describe a system that can be used for operational credits as opposed to EVS, which refers to a system used only for improved situational awareness. See definitions in Annex I. There is an option to allow EFVS operations without specific approval where the equipment is not used below 200 feet and where the RVR is not less than 550 meters. This information will be presented in the AFM, usually in the form of a table of visibility credits for different weather conditions. In order to allow operators to take advantage of EFVS, this AMC allows the RVR to be determined in accordance with the demonstrated performance as shown in the AFM. Use of EFVS in a non-precision approach. The regulatory framework allows the use of EFVS approach, EFVSA, or landing, EFVSL, in a non-precision approach. The EFVS equipment has an offset limitation, usually about 3 degrees to 5 degrees, that must be observed. Therefore, NPA with offset above the EFVS maximum certified offset limitation should not be flown. Thus, NPA should be flown traditionally, and no operational credits can be obtained. The new European AWO regulatory system follows the principle that EFVS should be certified, and the performance assessed. Therefore, the RVR minima should be determined in accordance with the AFM for the expected weather conditions. Operational credit for the old Cat 3A RVR 200 meters can be credited to Cat 3 as follows. Option A, prior approval, grandfathering. The operator does not amend its training and checking program to reflect the new minimum 175 meters and instead, it keeps 200 meters. The operator amends its SOP and manuals only to reflect the replacement of Cat 3A to Cat 3, editorial amendment. However, the operator maintained an RVR of 200 meters. The operator notifies the authority about the replacement of Cat 3A to Cat 3, if the operator is entitled to perform those amendments without prior approval. The authority amends OPS spec to reflect the new naming convention regarding Cat 3 and maintains the RVR 200 meters in the new OPS spec form. Note the operation specification is part of the certificate of the AOC and therefore if there is a change of the scope of the operation specification. Option B. The operator amends its training and checking program to reflect the new minimum 175 meters. The training should highlight the new visual scenario, visual cues, at DH. From 200 meters to 175 meters the difference is about 1 light difference in the center line. The operator does not need to conduct an additional simulator check, however, the next regular OPC-LPC EBT module should follow the new amended values, 175 meters. The operator amends its SOP in accordance with Cat 3 RVR 175 meters. The authority may amend operator's OPS spec at the same time it approves the operator's training and checking program and SOPs. Special approval for Cat 1. A new operation credit for SA Cat 1 with a DH of 150 feet or above and an RVR of 400 meters or above. SA Cat 1 is an evolution from LTS Cat 1. However, the approval of LTS Cat 1 cannot be credited directly to SA Cat 1. This new certification specification ensures that Autoland, or alternative technology, maintains the center line even with a lower performant ground equipment, Cat 1 instead of Cat 2. Thus, automatic credit from LTS Cat 1 to SA Cat 1 should not happen, even if the minima proposed by the operator of the new SA Cat 1 is the same as the LTS Cat 1. OTS Cat 2 credit to special approval Cat 2. The old OTS Cat 2 can be credited to SA Cat 2 as follows. Option A, grandfathering. The operator does not amend its training and checking program. The operator amends its SOP and manuals, including OMD, only to reflect the replacement of OTS Cat 2 to SA Cat 2, editorial amendment. The operator notifies the authority about the replacement of OTS Cat 2 to SA Cat 2, if the operator is entitled to perform those amendments without prior approval. The authority amends OPS spec to reflect the new naming convention in regard to SA Cat 2 and maintains the RVR 2350 meters in the new OPS spec form. Option B. The operator amends its training and checking program to reflect the new SA Cat 2. The operator does not need to conduct an additional simulator check. The operator amends its SOP in accordance with SA Cat 2. The authority may amend operator's OPS spec at the same time it approves the operator's training and checking program and SOPs. Note, there will be a transition phase from the chart providers where the replacement of OTS Cat 2 to SA Cat 2 will live together. For Special Authorization Category 2, SA Cat 2, operations, the following should apply. The DH should be determined by the use of a radio altimeter or other device capable of providing equivalent performance, if so determined by the aircraft certification process, and be not lower than the highest of the minimum DH specified in the AFM, if stated, the applicable OCH for the category of airplane, the DH to which the flight crew is qualified to operate, or 100 feet. The following visual aids should be available: approach lights as specified in Table 9, precision approach runway markings, Category 1 runway lights. The lowest RVR minima to be used are specified in Table 9. Equipment certification for operational credits. The details of the equipment requirements for certain types of LVOs and operations with operational credits. In the AFM, as the equipment of super fail passive has been demonstrated as suitable for use down to 150 meters, operators with such aircraft could consider applying for an Ultimosi. The minimum RVR for DH below 50 is 125 meters in the current rules, based on a fail-passive rollout system. This has been retained, but based on input from an aircraft manufacturer, a provision has been inserted to allow a minimum RVR of 75 meters where this has been demonstrated during the equipment certification process. The new IKO, Annex 6, definition. Category 3, a decision height lower than 30 meters, 100 feet, or no decision height, and an RVR less than 300 meters or no river limitation. AWO manual will evaluate the fail passive and fail operational Cat 3 and the associated values similar to the European rules. Null regulatory references refer to specific approval criteria. To obtain specific approval as required by regulation, the operator shall demonstrate that low visibility approach operations or LVTO operations in an RVR less than 125 meters, and operations with operational credits, the aircraft has been certified for the intended operations. The flight crew members are competent to conduct the intended operation, and a training and checking program for the flight crew members and relevant personnel involved in the flight preparation has been established. Operating procedures for the intended operations have been established. Any relevant changes to the minimum equipment list have been made. Review the minimum equipment list to update the new terminology. Each individual operator should assess the impact of the regulatory changes regarding LVO operations on its particular MEL, and propose the appropriate changes to the MEL, if necessary. AWO training requirements. EVS training. The training part of SPA. LVO is referred to as flight crew competence. The material has been expanded, providing more details. The competency to conduct the intended operations required is specified in the first 3 AMCs. Training for EVS must address all flight operations for which the enhanced vision display is approved. This training must include contingency procedures required in the event of system degradation or failure. Training for EVS used for situational awareness should not interfere with other required operations. Training for EVS used for operational credit also requires training for the applicable HUD used to present the enhanced visual imagery. EVS training should include the following elements as applicable: understanding of the system characteristics and operational constraints, normal procedures, controls, modes, and system adjustments, EVS limitations, EVS airworthiness requirements, enhanced vision display during low visibility operations, including taxi, takeoff, instrument approach, and landing. System used for instrument approach procedures in both day and night conditions. Failure modes of the EVS and the impact of the failure modes or limitations upon crew performance, in particular, for two-pilot operations. Crew coordination and monitoring procedures and pilot call-out responsibilities. The transition from enhanced imagery to visual conditions during the runway visual environment. Rejected landing, loss of visual cues of the landing area, touchdown zone, or rollout area. And any effects that weather, such as low ceilings and visibilities, may have on the performance of an EVS. LED runway lighting may not be visible to crews using HUD EVS due to the fact that LEDs are non-incandescent lights. Operators must revise their operations manual and checklists to include information guidance on standard operating procedures. Manuals and checklists must be submitted for review as part of the operational credit process. Practices and procedures in the following areas must be standardized and include ground and flight procedures and flight crew qualification requirements. Definitions. Check that crew was qualified for EVS operations. Malhandling. Equipment required for EVS operations. Types of approach where EVS are approved. A statement that autopilot flight director should be used whenever possible. Minimum visual references for landing. Before issuing approval for low visibility operations, the competent authority should verify that the applicant has taken account of the relevant airworthiness requirements and limitations. Established the relevant aerodrome operating minima. Established and documented the relevant operating procedures. Established and conducted adequate training and checking programs. Adopted the minimum equipment list for the LVOs to be undertaken. Processes to ensure that only runways and instrument procedures suitable for the intended operations are used, and established and conducted the relevant risk assessment and monitoring programs. LVTO low visibility takeoffs under AWO. LVTO, definition changed to cover RVR less than 550 meters, but special approval is required from RVR of less than 400 meters. The requirements for LVTO are down to 125 meters from the existing AMC 1 SPA, LVO 110, and it incorporates European Union. All-Weather Operations Manual Aviation Safety Agency draft version for consultation by October 15, 2022. The requirements for LVTO in an RVR of less than 125 meters also allow for the situation where equipment is certified for takeoff in lower values of RVR than 125 meters. This is to facilitate the future implementation of new technologies that could have different capabilities. AWO effect on ISA fuel energy schemes. AWO also have consequences in the fuel schemes as far as aerodrome selection policy covered in CAT OPMPA 182, and indirectly in the implementation of Regulation EU 2021-1296 and ED Decision 2020-2002 are on basic and individual fuel schemes. After 3010-2021 requires prior approval are related to the fuel schemes, Regulation EU 2020-1296. The aerodrome selection policy linked to the approval of fuel schemes. In-flight fuel management policy linked to the approval of fuel schemes. Special refueling procedures and defueling. Operators will only have to apply the AMC relevant for the variations to the basic fuel scheme that it intends to use. For example, an operator decides to implement only the variation covered by AMC 6 CAT OPMPA 181 is not required to include flight monitoring capabilities in its operational control system. Flight monitoring capabilities are required only when implementing AMC 8 CAT OPMPA 182 or AMC 9 CAT OPMPA 182, or both. If the operator has decided to implement all the planning minima covered by the AMC, on the day of operations the operator can choose any of the three options, depending on which is most favorable. Basic fuel schemes do not require flight monitoring when no variation to the planning minima is used in the aerodrome selection policy. Variations to the basic fuel schemes in the selection of aerodromes regarding the planning minima are methods to reduce the meteorological margins based on the established mitigating measures. The operator should establish an operational control system that includes flight monitoring when it applies. When flying to an isolated destination aerodrome, use a variation to the basic fuel scheme, covered in AMC 7 CAT OPMPA 182. To apply this variation, the operator needs to take into account other aspects of the fuel schemes, such as the safety margins for meteorological conditions that should be applied to that isolated aerodrome, for example, ETA plus 1 hour, or the planning minima of the such isolated aerodrome. For these matters, the operator usually will follow the requirements for the basic fuel scheme. Summary. This course is an introduction to the latest AWO from ISA that take effect on October 30, 2022. The course includes new terminology, changes in RVR requirements, and DHA and MDAH, which can be used outside of LVO to allow operators to expand their operations with the use of operational credits from advanced flight systems. Congratulations! You have successfully completed the lesson. Please wait. Program will prompt you to continue.